You're probably wondering why I'm in a basement and whether I was kidnapped or not. I'm actually here to learn more about thermal battery systems. Nearly 2/3 of US households use electricity and another type of energy source. That energy source happens to be natural gas. I'm here today with my good friends at Harvest to learn about this thermal battery system that is revolutionizing energy, and we're going to learn about this today. Hi Jane, thank you so much for inviting me. I'm delighted to be joined by Jane Melia, the co-founder and CEO of Harvest. Thank you so much again for being here.
Well, thank you for having me. It's great to chat with you, Isaias, today.
Of course. I think this is such a unique episode because I think I haven't really delved much into energy. And you're like the energy guru I want to ask everything about is, what is Harvest's mission and what do you all do?
So Harvest, what we're building is really the smartest heating and hot water on the planet. It's about how do you give people a really, really comfortable home that's affordable, saves them money, and that actually helps beat climate change.
And Harvest is not just a heat pump. It's a heat pump and smart thermal battery system.
Yeah, absolutely. And essentially what we're trying to do is figure out how do we heat your home in a way that's going to use the cleanest electricity possible, that's going to be the most efficient and save you money. And for doing that, what we're doing is we're taking heat pumps and we're combining them with some controls and thermal battery that really makes the overall system behave in a much better way.
Yeah, I mean, I'm curious to know about our current energy grid and here in the United States where we're based. What are the current issues and what are the current issues with homes specifically?
There's a lot to unpack there. So first of all, did you know that a massive 2/3 of the energy used in our homes is for just two things, heat and hot water?
Yeah.
I certainly didn't know that before I started on this journey. It's a lot. And most of that is from burning gas in our furnaces and water heaters. So what that means is, we can put solar panels on our roofs, which is great, but as long as you've got gas combustion engines delivering your heating and your hot water, you're only addressing a small part of the pie. Now, the exciting thing is that we have alternatives. Heat pumps are amazing, right? Heat pumps are electric devices, and what they're doing is moving heat rather than generating it. They're extracting heat from the air outdoors, even when it feels cold outside, and bringing it into the home. And they are so efficient because they're moving heat. They can be 300, 400, 500% efficient.
Heat pumps are very exciting because I think they've gotten so much popularity over the last few years. And I want to know, first of all, have heat pumps existed for decades before? And second, why is there such a upward trend in popularity? Is it because it's now cheaper to afford? Is it because it's more efficient? Or is it because there's now a demand in that market?
Yeah. So I think it's all of the above. So heat pumps have been around for decades. And they used to have a bad rap because it didn't always perform well when it was cold. They didn't necessarily deliver very stable heat. They weren't always very efficient. They have improved so much. But also, I think more and more of us are learning about the challenges of climate change. And so a highly efficient electric system that can draw clean electricity from the grid is going to be better for the planet than burning gas in our furnaces. So that's a trend which is happening.
And I'm very curious to know about the story around Harvest because I think it's first of all, it's such a beautiful name. I mean, I think about energy, I think about gathering, I think about community, but I'm very curious to know what was the story behind this system of trying to automate homes, which is something that it is true we don't often think beyond of just installing solar panels in our home, but not thinking about what else is being powered in our home.
Yeah, so it is a bit of a personal story. So just for background, so I've been working in clean energy startups since 2008 in concentrated solar, in energy storage, in solar cells. So it is part of what's important to me. And then back in 2017, my old gas furnace was about to die, and I'm thinking, well, gas furnace, that's methane gas. If I put another gas furnace in, it's going to be there for 20 years. I don't want to do that.
Oh, they last for that long?
Oh, yeah. Oh. So if you put a furnace in today, you're committed. Well, I mean, you can always replace it, but typically it's going to stay in for 20 years. So you're creating a problem for the future. So I thought, well, I can't put another gas furnace in. I'll just put a heat pump in because heat pumps are so efficient and then they're electric. And then I realized, well, there's a problem, because when do I need to heat my home? It's at night and in the morning. And you know what? There is no solar electricity on the grid at night and in the morning. So if we all switch from gas to electric and we use those to heat our homes at night and in the morning, we're adding load to the grid at the times of the day when we're using gas to generate electricity. So you get this conflict between cleaning up our homes, cleaning up the grid. And so we thought, me and my co-founder, that, well, there has to be a better way. And what we're doing is, let's take the power of that heat pump, that efficiency, that high performance of the heat pump, and let's make it a little bit smarter by combining it with a storage device. And that storage device is thermal storage, right? So it's not the electrochemical battery that you might use for your EV or for your television or your dishwasher. It's thermal storage. Essentially, it's a hot water tank. So run that heat pump when electricity is clean, cheap, and abundant, and when that heat pump is going to be most efficient. Store that energy in a hot water tank, which is carefully stratified, and we carefully manage it and control it. And then we can deliver all your heating and your hot water just whenever you need it. So what does that mean? That means we're running the heat pump at noon. There's a lot of solar electricity on the grid at noon.
Yeah.
Your time of use rate is going to mean your electricity is going to be cheapest, and it's also, the heat pump is going to be most efficient. So you win financially both ways, more efficient and lower rates.
In long-term theory, with harvest, do you see this becoming a more nationally adopted practice in America?
Yeah, absolutely. I mean, grid flexibility is really important. As we clean up the grid, we need to have what they call flexible loads. We need to be able to shift loads to different times of the day, or shift electricity use to different times of the day. So that is becoming more and more important. We can see that, for example, in some of the tax code, where you get a significant tax credit, 30% tax credit, if you include storage, not just for regular heat pumps. So 30% tax credit is all about battery storage and thermal storage. So that really underlines how important storage is to the electricity grid. It's really hard for us to electrify our homes and have a clean and reliable and cost-effective grid if we don't use storage and we don't shift loads. So I see this as really as the future of heat pumps. I see that in 5-10 years, pretty much every heat pump will have thermal storage capacity to be able to shift that load to whenever makes the most sense.
Myself, I had this experience living in the Bay Area. I remember we use heat and probably powered by gas. And our energy bill for 1 month, in the month of, I believe, October, November, was almost $500, $600 for a house of only 5 people.
Yeah.
And that really shook us to the core when we realized electricity is not cheap.
Yeah.
And it's only cheap in certain areas because it's either powered by predominantly natural gas when I lived in different states. So, for people that are struggling right now to wanting to, adopt and transition to this technology, what are the best ways of programs out there that have helped them, transition? Was it through the rebates? Was it through different incentives?
Yeah, so there are a lot of incentives and tax credits available. Tax credits, of course, are at the national level.
Yeah.
They're really very supportive to help people transition to heat pumps, and in particular storage. And so that's a really good opportunity to get the cost down. And there are rebates. I'm sitting in California. There are a lot of rebates for heat pumps, but there are also some in many parts of the country, and there are more rolling out with the IRA, the Inflation Reduction Act. More rebates are rolling out, as we speak. So by the end of 2024 and early 2025, there will be a lot more than there are today. 2 years ago was the coldest winter in California for 25 years. And a lot of people saw their electric bills go up a lot.
Yeah.
And what we saw was, first of all, our heat pumps met the need. We kept everybody nice and warm and got all that hot water, so that works. But also, our system saves money in 2 ways, because if you can run a heat pump in the middle of the day rather than running it at night, it's going to be more efficient. Heat pumps operate better when it's warmer than when it's cold. So it's always warmer at noon than it is at 5 a.m. or 1 a.m. So you gain a lot of efficiency there. That saves you money. And also, most people in California are on time of use rates. And so we didn't have to run use that electricity at 8, 9 p.m. when it's super expensive. We could run it when it was cheapest. Harvest systems cut bills compared to regular heat pumps by about 30%. Month over month. And we cost about the same as a median heat pump system to install. But you're saving money. That means our payback is instantaneous. And you can use those savings to actually finance it. And that allows you to even avoid that upfront cost. So it really is, it's not just best for the planet, it really makes a lot of sense for your home economics and for your wallet.
Which is a lifesaver, because what I like to tell people is that it's not just the technology you're buying, it's an adaptation strategy.
Yeah.
And especially in an overheating world, we have to reimagine our relationships of what we're consuming. And do you see Harvest in the future working with more governmental agencies to help roll out the product and make it more national on that scale?
I mean, our job right now is to communicate, to share what's possible, because we have a product that works really well, but people don't know we exist. We have, hundreds of customers, but people don't yet know our name. So our job right now is to say, we're here, we're ready to serve you, we're ready to support you, we're ready to put you in touch with a contractor in your zip code and get a system installed and, save money, have a comfortable home, but also be part of a climate solution. Okay, let's talk about the duck curve. You are now a grid operator.
Oh my God.
Okay, and this is a day of your life between midnight and midnight. And what you're having to manage is you've got high emissions and costs in the morning and high emissions and costs in the evening and lots of clean, cheap solar in the middle of the day. Here, you've got high dollars and high emissions in the morning and the evening. So, what's happening? 2/3 of the energy used by our homes is for heating and hot water.
Yeah.
And more heat pumps were shipped last year than gas furnaces. So people are transitioning to electric. What can go wrong? Well, we all need to heat our homes at the same time, as typically mornings and evenings. And what we're doing is adding load to the grid here, and then again here. And so we're making your life harder. Because heat pumps are fantastic, right? I mean, they are the right thing to do. I applaud anybody who installs a heat pump, but this is very challenging from a grid perspective. We're adding load in the morning. We're not capturing as much solar as we could. The future of heat pump has to take a different shape. This is the shape that a Harvest heat pump uses. This is when a Harvest system draws electricity. In fact, one of our customers, a lovely lady called Lana in Oakland, said it's like an upside down duck, right? This curve, the black curve, is the duck, and Harvest just fits in upside down. Well, what's happening? Because we can choose when to run the heat pump, we're always going to run it when the heat pump's most efficient, i.e. when it's warm, when electricity is cheapest and cleanest, usually in the middle of the day. We store it up in a thermal battery, but you get your heating and hot water whenever you need it on the red line. We run it, we store the heat, and deliver it later on. So what we're doing now is really making your life easier, because not only are we saving money for the homeowner, we can use a lot of that solar electricity that you generate. In fact, we can allow you to install fewer gas peaker plants, maybe even close down gas peaker plants. So it's not just making homes cleaner and cheaper, it's making the grid more reliable and more sustainable, because you can use more solar electricity as well.
So my question is for homeowners is that, you're not only just saving money from emissions, but also the cost. You're also being an advocate to divest away from these natural gas plants that are nearby that are pulling in energies locally in your community. And that's really amazing, because I didn't know you can do that. And have you seen cases where, the demand for gas is going down because of these?
This is a way to make that win-win, where we clean up our homes and we can help the grid get cleaner at the same time.
And you're decarbonizing it here.
Yeah, but it's also getting more robust, because we are naturally always using electricity when it's cleanest and most available, when it's cheapest. And we're avoiding those times when you might have, say, restrictions, where you might have challenges in terms of grid capacity. We have the ability to respond to a grid signal. The grid says avoid these times, we can avoid them. And we will do, and we just integrate that in the operation. And you as a homeowner or as a renter, it doesn't impact you in any way. You still get your heating whenever you want, but the smarts of the Harvest Smart Thermal Battery allows us to use the heat pump whenever it makes the most sense for the grid.
Let's say that there's like a hurricane or a severe winter storm. I know that there's been cases in the United States where people, have lost access to heat and water. So
we still are reliant on electricity, but we do have some advantages. Because we're using that tank as a thermal battery, we can store a lot of heat in that tank. And what that means is you can have hot water for your showers for days after a power outage. All right,
Whoa,
so that's helpful. And so that gives you some resiliency. In fact, in my house, there were some power outages. I think it was a couple of years ago in the fall, and we didn't actually need heat at that time, but we were out of power for about 48 hours. We had plenty of hot water, and it was really nice. And so that's what Harvest does. We heat your house whenever you want it. It's just that we use the electricity at a different time, and that is what's smart about Harvest.
Thank you so much for showing me about the duck curve, because I literally have been curious my whole life about, what does this really mean? Like, are we drawing an animal? But now it looks like this duck is happier than the other two ducks on this side.
That's right.
Yeah. Now that we talked to Jane about heat pumps and a thermal battery system, we're going to talk to Pierre, the head of product, who has designed this and also the co-founder of Harvest. Thank you so much for being here today.
Of course, thank you, Isaias.
What exactly do we have here and the one behind us here on this end?
Yeah, this is where most of the components of the Harvest system are installed. We have the Harvest pod, which is both the heart and the brains of the system.
That optimizes everything.
Yes, it controls the different components, and it's a hydronic system in a box. When in a normal home, you would have lots of pipes and pumps and valves on the wall in the basement. That's for homes that have hydronic heat, so basically water-based heating, like a radiant floor. And it's all site assembled. It takes a lot of time and expense to install. So what we did is we integrated all this down into a box. So we have basically a hydronic system in a box, and all the pipes and valves are factory assembled and tested, and it's just plug and play by the installer in the home. We actually achieve higher energy efficiency than a standard home battery. Like the Tesla Powerwall is about 92% efficient when it's new. This is 95% efficient, and it does not degrade over its life. Electrochemical batteries like Tesla and others are great for when you need them on the go, like in a car or for your lights, because they store electricity. But for heating and hot water, you want to store heat, not electricity. It's much more efficient to store it in a large water tank at high temperature, highly insulated, so that it stays hot from one day to the next.
This is so amazing, because I never knew that you can compartmentalize everything in just one box. Are we able to open the box?
Of course, let's do that. Remove the cover, and here we go. So this is the hydronic section, and this is the electronic section on the left. The hydronic section, the plumbing components, you have advanced flow meters, which are able to detect very low flows at very high accuracy. You have a high efficiency pump that will circulate water to the air handler and back from the air handler. The fan will blow air through the coil, just like a car radiator, extract the heat from the water and return cold water back to the tank.
Oh, so it's like a circular system.
It's a circulator system, so that's the circulator pump. It's a very high efficiency pump. It just takes a few watts, about 5 watts. It's like it's less than a light bulb, an LED light bulb. What this thing does, it turns a dumb hot water tank that most people have in their house. They have a tank in the closet or in the garage or in the basement, but the normal tanks, we don't know how much charge they are, and typically they're left on all the time. We know exactly how much hot water is in the tank. So imagine that tank as a thermal battery. The top part of the tank is going to be filled with hot water at 150 degrees, and the bottom part of the tank is going to be at cold water between 60 and 80 degrees. That way we can partially charge the tank or charge it as much as we need for the occupant's needs.
Wow. And Jane mentioned that there was a time where electricity shuts off. This doesn't shut off itself. It still continues to be able to produce hot water for homes.
You won't be able to run the heat pump, but you have a lot of storage in the tank. So if you just use hot water, you have several days, maybe up to a week of, depending on how much you use, right? It could be less than a week, but you at least have 3 to 5 days of hot water reserve in that tank.
Obviously, you've done so much research, engineering, and design for these products. What came for your inspiration specifically when it came to energy? Was there a certain story that you have of your background?
My first career was in computer technology.
Oh, cool.
And then I moved into climate policy, and I was looking at how do we decarbonize homes and how do we make sure that homes are in harmony with renewable energy. Let's take the biggest source of energy consumption in homes, that's heating and hot water, 2/3 of home energy consumption, and make it flexible to be basically in line, to be aligned with energy availability, with renewable energy, solar energy, and wind energy availability. So that's what this box does. It basically shifts the time when the heat pump runs and uses electricity to the times when there's plenty of renewable energy on the grid, and then it shifts to the battery as a source of energy for the home when there's a scarcity of renewable energy on the grid.
What would you tell young engineers out there, like how can they get involved more in climate technology?
There's a lot of applications of computer technology that can make what we do every day smarter. Just like, an electric car is basically a computer on wheels, and computer and a battery on wheels. What Harvest is a computer and a thermal battery with a heat pump, and it's turning a standard heat pump into a smarter heat pump, smarter system that is basically renewable energy friendly.
Some of the concerns that a lot of people have are minerals. So the minerals that are being sourced, where are they coming from, and how does Harvest really work with that?
Yeah. Well, the beauty of using a thermal battery for thermal energy storage is that it doesn't have any of these conflict minerals or rare earth minerals, which are difficult to mine and source. It's basically it's a hot water tank. It's steel and insulation, and it's very, from a material perspective, it's very cost effective.
What do you see in the future for Harvest? Like, do you see this being adopted also within large scale buildings and like commercial properties, or do you see it more focused on home first and slowly expanding itself?
Yeah, so we started with single family homeowners who are, people who tend to be early adopters and most interested and concerned about climate or just energy costs. Some of our customers are really climate driven, and some of our customers are just cost driven. They just want the system that's going to provide them the cheapest energy cost over time, over the life of the system. We're going to continue to grow in this market and expand beyond the Bay Area, which was our launch market, and go, now we're expanding up and down the West Coast and on the East Coast as well. So we want to make sure that people who are, have lower income can access this technology and can access its benefits, which is to basically reduce how much of their disposable income they spend on energy month after month. So we are working with property owners to install the technology in this multifamily apartments. That's our next step.
Yeah, I mean, this is something that is rapidly moving as we speak, and many of us probably here need to start switching to Harvest because, I know I would in a heartbeat if I had my house to be like, I'm switching out everything and getting rid of all of the nasty emissions that are making my grid dirty, but also really a way to save money and save the planet. So thank you so much, Pierre, for this. This is so amazing.
Thank you.
Now that we learned more about the thermal battery system here at Harvest, I'm joined here by Kartik Lamba, the Director of Hardware Engineering, and I'm very excited to know what your role is here and what you do.
Thanks for having me. So my role here at Harvest is the head of hardware engineering, and so our team is in charge of the engineering of the pod, which you saw earlier, as well as some of the other kind of custom hardware components we have in our system. And what we have here is a kind of a selection of various generations of our hardware, from kind of the earliest, which was kind of on the far left over there, which was using an off-the-shelf kind of single board computer. And then we've got this is the Prelude model, which is kind of a second gen model for us, and then kind of progressing into kind of the more modern iterations of what we built.
I'm really curious to know why did it go from this large piece to this small piece we have today?
This is kind of the electronics that are the brain of the pod. And so this is controlling, it's connecting to all the sensors. We've got a lot of temperature sensors, flow sensors, pressure sensors that are kind of measuring various aspects of what's going on in the thermal battery and in your home. And then it runs a fairly intensive algorithm to kind of figure out, okay, when to charge a thermal battery, when to discharge it, how much to charge it, things like that.
Does it use AI or is automation, or is that more than a different system?
We do have some algorithms that run on here. I may not call it AI, but there's some fairly complex algorithms to, again, determine, when to charge, when to discharge, how much energy to use in a given day, so that we're kind of optimizing for a particular home.
What advice would you give to young engineers that are studying right now for their degree and knowing that there is a plausible way to earn money? Because I think that when we think about environmental jobs, for example, people think about nonprofits and they don't think about climate tech companies right now.
Yeah, I think the advice I would give to to engineers studying in school is that you can work on at interesting product development companies, working on a product that both can help the environment and also be a good business.
Clearly building out this product wasn't easy, and as an engineer, I kind of want to ask you, what were some of the challenges and hurdles and also the new developments that you've been able to add to this product?
From a product standpoint, one of the challenges that we've had are simply that there isn't really a product like this on the market, right? And so figuring out how to architect it, essentially what is essentially a brand new product, was probably one of the biggest challenges.
What are the things that excite you next for Harvest? Because I think that this company is always developing something new. You're always trying to make it more efficient, more optimal for customers. What are the things that you look forward to, or what you would hope to see with this product?
So far, we've developed a really good, first or even second generation product. And it's a great, as any startup, you're trying to get an MVP out there, a minimal viable product. And I think the next steps are, now that we feel like we've developed product market fit, is starting to integrate more of the components to make it a little bit more seamless, so you can make the product more integrated, lower cost, easier to manufacture, and just a better product overall for both homeowners to have in their homes as well as contractors to install.
Thank you so much for giving me the download on the engineering side, because I think this is something that is very important for a lot of climate tech companies, is that engineers are not just trying to find the solution, they're trying to always find solutions that exist. So multiple solutions than just one. And this is just another example where I feel that we need more engineers in this field to be doing these products, because people like us maybe get confused out there, but we have people like you that are doing this work.
Yeah, thanks for having me here today. Hopefully, you and your audience learned a little bit about what we're building here at Harvest, and kind of regardless of what they may be interested in, there's likely a role for them at a climate startup.
Well, there you have it. I wasn't actually kidnapped. But what I did learn today on this episode of Sustainable Jobs is that Harvest is revolutionizing the energy industry of not only saving the planet, but saving money at your home. Let's make sure to heat our homes, not our home planet.